Okay, in this video we're going to discuss project planning and specifically the critical path method. So there are a number of ways that you can do project planning. You could use something that's called a Gantt chart. You could use PERT or probabilistic evaluation and review technique, or what's known as the CPM, which is the critical path method. So the critical path method, or the CPM, which is what we're going to be discussing today in this video, is a deterministic technique, so there's no variability, and it estimates the completion of each time activity using a single time estimate. So why might you want to engage in something like critical path management or CPM? Well, you might want to know, when is a project going to be completed? Which are the non-critical activities within a particular project? Is the project on schedule, ahead of schedule, behind schedule? We can decide whether or not the project is over or under budget. We can discuss whether or not there's enough resources to finish the project on time, and the list goes on. There are a number of different questions that project planning or project management planning can help us answer. So there are 6 basic steps to critical path management, and that is simply, we have to define the project and all of its significant activities and tasks. We have to develop the relationships amongst these activities, so we have to determine which steps are immediate predecessors. So in other words, what are the activities that tasks must be completed before the next activity can begin? We're going to draw the network connecting all of the activities. We're going to assign time or cost estimates, or both, to each activity. And then importantly, what we're going to do is we're going to compute the longest time path through the network. And your longest time path through the network is also known as your critical path. And then finally, we're going to use the network to help schedule, monitor, and control the project. Okay, so this will all make sense in a second. Now, when we're looking at kind of network diagrams, there are 2 basic types. There's what's called the activity on node and the activity on arc format. A lot of softwares use the activity on node format, so that's what we're going to be using in this video. So let's dive into our question after that relatively long preamble. As the project manager for a new software development initiative at your company, you are tasked with overseeing a critical project aimed at developing a new software application. This application is expected to play a key role in the strategic growth of the company by enhancing operational efficiency and enabling new customer services. The project involves multiple specialized teams and a series of interconnected tasks, each critical to the successful completion of the project. As your primary objective is to ensure that the project is completed as efficiently as possible, adhering to the highest standards of quality, timely delivery is paramount to capitalize on the market opportunities and to meet the expectations of shareholders or stakeholders. Given the complexity of the project, meticulous planning and effective management of task dependencies and timelines are essential. Here are the tasks along with their duration and dependencies. So we have a description of our tasks here. We have our duration, or how long each task will take to complete, as well as which tasks are predecessors of that particular activity. And this will make sense in a second. So the completion of this project is on schedule, is expected to significantly enhance your company's capabilities and market position. Your task is to devise a schedule that aligns with these objectives, ensuring that all project milestones are met efficiently and effectively. So as I said, we're going to go with the activity on node format. And before we get started, why don't we just talk about kind of a general structure of how we're going to structure our nodes. So if we just want to look at our node, we're going to create a node that looks like this, and we can draw 2 lines, and we're going to divide that into quadrants. In our top left quadrant, or our northwestern quadrant, we're going to have what's called our ES, where ES is equal to earliest start. We're then going to have EF, which is our earliest finish. we're going to have then LF, which is latest finish. And we're going to have EF, and you guessed it, stands for earliest finish. We're going to put a few other variables in here. We're going to put X right here, where X is equal the duration. And we'll label this alpha, which will just be the task, okay, to keep it all organized. Okay, so now that we've established how we're going to draw our nodes in this particular project, let's go ahead and start with drawing our nodes. So let's look at where we're starting. Well, we're going to start with task A, and we notice that there are no predecessors, so task A starts at time 0, 0. Okay, so let's draw our node. We'll label this A. Our earliest start is at time 0, right? We notice that it takes 8 days to complete task A, which means that the earliest finish is simply 8 days from the start, so 0 plus 8. 0, let's say this is the earliest start plus the earliest, plus the earliest start plus X, where X is our duration. So this is equal to 0 plus 8, which is equal to 8. Okay? And we're just going to erase this just because we're going to have to keep our network diagram fairly clean here. We then notice that we have 2 other events that happen right after A. So what are the 2 events that happen? Well, B happens and C happens. Okay, so let's go ahead and draw this. So we'll draw another node here for B. And we'll draw another node for C. Again, we'll divvy this up into 4 quadrants there. Well, let's just address our durations first. So task B has a duration of 8 days and task C has a duration of 12 days. So 8 and 12. And we know that before B can start or before C can start, A must be complete, which means that the earliest start for B is equal to the earliest finish of A. So this is 8. The earliest start for C is equal to the earliest finish for A, also 8. Which means that the earliest finish for B, that's right here, is simply going to be 8 plus 8, which is equal to 16, right? This is 8 plus 8. So we write, we write 16 in there. For C, 8 plus 12 is 20, which means that the earliest finish for project C is after 20 days. Okay, now that we've done C and B, let's go and look at some other ones. So D, to do module D, B and C must be completed. Okay, so let's put this in here. So we'll draw another node here. So D, B, and C both must be completed before D can start. D takes 18 days, right? We get that from right here, 18 days. Now, the earliest start for D, given that both B and C must be completed, the earliest start for D is simply equal to the earliest finish for C, because C takes the longest time. So the earliest start for D is 20 days, which means that the earliest finish is 20 plus 18, which is 38 days for D. Let's move on to E. So for us to start E, B must be complete. So we'll put E right here. We notice that it had a duration of 20 days and that B must be complete before we start E, which means that the earliest start for task E is as soon as B is complete, we can start E, which is at 16 weeks, which means that the earliest finish for E is 16 plus 20, which gives us 36 days. Sorry, I said weeks, I meant days. Okay, so now that we've done E, we can then look at, which we've done E. Now we have to do F. So F is simply, we need to have completed C before we can do F. So F can go right here. And again, we'll draw our node. Looks like this. How many days does it take to complete F? Well, it takes 15 days to complete F. And the predecessor is C. So C must be complete before we can start F. So if the earliest finish of project C is 20 days, then the earliest start for project F is 20 days, which means that the earliest finish is 20 plus 15, which gives us 35 days. That's our earliest finish for project F. Okay, now we're going to keep going. Project G. To do project G, project B must have been completed. Okay, so let's put project G over here. So G is right here. G takes 14 days. And B must have been completed before we can start G, which means that the earliest start we can start project G is after 16 days. I don't know why I put, oh, this is 14. Yeah, I had it right. Just a little sloppy. So 16 plus 14 means that our earliest finish for project G is after 30 days, right? So our network diagram is starting to get a little tricky. But that's okay. Let's do ourselves a little favor here and let's just move project E. And all we're going to do then is just move that just so it looks a little cleaner. Now, we can move on to project H since we've done the rest. So project H, what do we notice? Well, D, E, F, and G all must be completed. Okay. So project H. H takes 12 days to complete. And D, E, F, and G. So D must be complete. E must be complete. F must be complete. And G must be complete in order to start project H. Now what we have to do is we have to identify, well, what is the earliest possible start that we could start project H? Well, in this case, the earliest possible start, given that project G, E, D, and F all have to be complete, we're looking for the largest earliest finish or the max earliest finish. So in this case, it's going to be 38 weeks that we got here in project D. Or 38 days, sorry, I keep messing up weeks and days, but 38 days, which means that the earliest possible finish of project 8 is 38 plus 12, which brings us to 50 days. Okay, we're almost done our network diagram. Now let's move on to I. So to do I, H must be completed. So let's just make this a little bit easier as we're running out of room here. I takes how many days? I takes 10 days. And H must be completed. So the earliest possible start is at 50 days. It takes 10 days, so the earliest possible finish is after 60 days. And now we're looking at J. So for J, I must be completed. So we have J. I must be completed. It's going to take 6 days to complete J, which means that the earliest possible start is 60 days and the earliest possible finish is at 66 days. So 60 plus 6 is 66. And then finally, our last one here is project K. And to start project K, I must be completed, right? We see that in our predecessor activity here, right? I must be completed to start K. We notice that it takes 8 days for project K. So the earliest possible start is at 60 days, which means that the earliest possible finish is at 68 days. And we can put in one more node here that's just end if we want. So our earliest possible start for end is 68 days. The earliest possible finish is also 68 days. So now that we've gone forward in our network diagram, we're going to go backward in our network diagram. So again, our latest possible finish is 68 days, which means our earliest finish here is 68 days. And now we just go backwards. So at 68 days, 68 minus 8 gives us 60. Our latest possible finish for project J is at 68 weeks. Minus 6 is 62. Right? Our latest possible start here is going to be our minimum. So 60. So 60 minus 10 is 50. So 50. 50 minus 12 is 48. Not 48. 50 minus 12 is 38. 38. Which means 38, 38, 38, 38. So 38 minus 15 is 23. 38 minus 18 is 20. 38 minus 20 is 18. 38 minus 14 is 24. So then what we're looking for here then is our minimum value. And for node B here, our smallest value. So our smallest value is at 18. And our smallest value here is at 20. So 20 minus 12 is 8. 18 minus 8 is 10. Again, we're looking for the smallest value here. So 8 minus 8 is then 0. So your network diagram looks like this. And now we can go through and we can identify our slack in our system. And to identify our slack, all we're going to do is we're going to take the latest start. And I apologize, this probably should have been latest start. So this isn't earliest finish. We've already done earliest finish. This is the latest start. So all we're going to do to identify slack in our system is we're going to take our earliest start and subtract, or our latest start and subtract our earliest start. So in this case, we do 0 minus 0, which is equal to 0. So we have no slack there. We then do 10 minus 8, which is equal to 2. So we have slack at node B, or at project B. At project C, we have no slack, right? 8 minus 8 is equal to 0. So there's no slack. There's no room for failure at project C. At project F, we have 3 weeks of slack, or 3 days of slack. At project D, we have 0 days of slack, 20 minus 20. At project E, we have 18 minus 16, which is 2 days of slack. At project G, we have 24 minus 16, which is 8 days of slack. We then look at project H, so 38 minus 38 is 0 days of slack. Project I, 50 minus 50, also 0 days of slack. Project K, 60 minus 60, 0 days of slack. Project J, 62 minus 60 is 2 days of slack. And then at the end we have 0 days of slack. So by going through and identifying the areas of slack, effectively what we're doing is identifying our critical path. So in this case, our critical path looks like, our critical path is the following. A, C, D, H, I, K. That is our critical path. So we would write our critical path here. So our critical path is equal to A, C, D, H, I, K, and that is our critical path. So basically any delay along our critical path will result in the project itself being delayed. As you'll see in other areas on our chart here, so we'll just change our highlighter for a second. If we were to look at project G for a second, we notice that there are 8 days of slack in project G. So G can be delayed up to 8 days and it won't have negative ramifications on our overall project completion. Okay, so if you were project managing this project, you would want to be very attentive to the days where there are no slack in the system, as any delay along your critical path will ultimately delay the completion of your project. And this has been a fairly long video, so we'll do project crashing in the next video. And that's it for this video. Thanks for watching. If this video helped make business analytics easy, consider giving the video a like. And if you need additional help with business analytics, please consider subscribing to the channel. I look forward to solving many more problems with you next time.